So welcome to the horticultural section with the chemical control for the e-learning module. So my name is Lynn Tatnall. I'm a weed biologist based at ADAS in the UK. In this section I will be covering different horticultural crop types with lots of variety between salad crops and vegetable crops, herbicide control, application technology in the different crops, tractor mounted systems, drone spraying and bioherbicides. So if we start with perennial crops in horticulture, these generally include bush and cane fruit such as blackcurrants, vineyards and fruit orchards. Perennial crops are grown at different widths between the plants and all have alleyways between the crop rows. A whole separate section of this e-learning module will cover vineyards and other perennial crops, so I won't be going into detail in this section. So moving on to the annual horticultural crops. These tend to be a variety of salad crops and field vegetables. They are planted in much wider space rows than arable crops generally. Weeds can affect yield as the crop grows as they compete for nutrients and water and light. Weeds also can be contaminants of salad crops, resulting in a rejection from the supermarkets. This could include something like groundsel in a salad leaf crop. Wider spaced rows for these annual crops often are grown in beds, so you quite often have 6 rows with alleyways in between, and the weed control is required in the alleyways but also within the plants within the beds. These are often very short-lived crops, so a salad crop like lettuce could just be a few weeks in the ground. A stale seedbed technique is often used pre-planting using a cultivation of the ground to stimulate weed emergence and then a herbicide such as glyphosate to kill weeds before the crop is sown. So herbicide control in horticulture is very important for a number of different reasons, and there's many different things to consider. These include maintaining crop yield for quality, as I've just explained about supermarket rejections. Crop row width can vary, but generally these are much wider space rows, so this must be considered. Herbicide choice is much more limited due to less products being approved in these minor crops. Herbicide resistance in weeds can also limit choice of herbicides and the efficacy of those. Often crops are grown in these short windows of time, so as I said, salad crops also quite often grown in a few weeks. Herbicides are often used pre-planting and within the crop. And you need to integrate chemical control with alternatives such as mechanical inter-row weeding. There's a lot of exciting new technologies emerging for precision spraying. So let's now move on to some of the new technologies available to help with chemical control. And we'll start with spray technology. So we have many tractor-mounted sprayers, and these for spraying whole fields, and this is a traditional method of chemical control. But there's now precision spraying, so targeted spot spraying are the much newer technologies. Often they're tractor-mounted systems, but there's also drone sprayers. Robotic systems are now available, but not always using herbicides. Quite often at the moment they're using lasers or mechanical weeders, but they may be something for the future. Handheld sprayers are still very useful on a small scale. You need to think about water rates of application and think about the crop type you're applying to. Nozzle choice and droplet size are also very important depending on the system you're using in the crops. And you almost always should read the herbicide label. Precision spraying, or spot spraying as it's sometimes known, is advancing all the time. There are tractor-mounted systems available commercially and they're used widely in vegetable crops. There are multiple cameras on the boom to detect weeds, often at a very small growth stage. The spray nozzles that can then turn on and off as required to control the weeds directly. The whole system works in real time, so there's no need to map the fields first. And one major benefit of this is to reduce the overall amount of herbicide used and precision of control. These systems can also be used pre-sowing and within the crop and integrated with mechanical weeding, so they're very versatile. Technology is advancing all the time, as I said, so something like the John Deere system has green on green, so that's in-crop technology, and green on brown vision, so in fallow systems. And they can also map where the weeds have been sprayed. But these are particularly popular in the UK in crops like carrots and onions. Also in this area are newer technologies, including the Eco-Robotics ARA precision spray system. This has 156 nozzles on a 6-metre wide boom to cover a vegetable bed. Target area is a weed area as small as 6 by 6 centimetres. The travelling speeds are about 7 kilometres an hour, and they can detect weeds as small as 2 millimetres. They can also inter-row band spray on more weedy fields. The spray nozzles are shielded by a hood, so they can be used in often slightly more windy conditions than a sprayer, and they reduce the overall herbicide use by up to 95%. They're used in the UK in carrots, onions and sugar beet. When considering spray application, the type of nozzle is very important, and there are newer nozzle types called pulse width modulation. These are specialist nozzles where there are individual control of each nozzle on the sprayer. Herbicide products can vary without affecting the spray pressure or the droplet size, and the nozzles can open and close as much as 100 times a second. These are very precise applications, reducing pesticide use and drift. Many companies now manufacture these nozzles, and they can be retrofitted to existing booms and systems, so this is a fairly cost-effective tool to use. The use of drones for spray application is now an up-and-coming area of interest. Drones can collect images of weeds to map patches and then spray the weed patches with direct precision. This is not yet approved in all of the EU and the UK, but has many approvals in the USA, so this is an area that we will see increase in Europe. The advantage of this is that they use less herbicides overall. The precision spraying is just of the target weeds only. This will help with soil health and also wider environmental benefits. And it's also perfect for hilly terrain and areas that are more difficult to access. Disadvantage though, unfortunately, because of the lack of EU approval, we're still not able to use it in all crops, and it does require the skill of a drone pilot. Moving away from application technology, there is another area of increased interest in chemical weed control, and that is bioherbicides. These are compounds that are found naturally from plant-based sources. Many aromatic and medicinal plants produce allelochemicals that can be toxic to some weed species. There are a limited number of bioherbicides commercially available at the moment, and it must be remembered that these bioherbicides are regulated, so they are approved for use in the same way as a traditional herbicide, so they are still classed as chemical products. They are often not selective, but are a very good alternative to conventional herbicides. There is a lack of uptake often, and that's linked to maybe a lack of evidence for efficacy or the high cost of these products at the moment. Examples of bioherbicides include products from compounds such as the mint family, the Laminaceae, or citronella oil, which comes from lemongrass, vinegar and other acids, and garlic oil. Hydrosols that are low-cost byproducts of essential oil extraction are often used as bioherbicides. And bioherbicides can either inhibit seed germination, so you can apply them to the soil to stop weeds germinating, or they can be used as a foliar spray. So to try and summarise the use of chemical control in field horticulture, herbicides are still a very important tool to control weeds. Herbicides must be used correctly to maximise the efficacy and prevent resistance risk. You need to understand the products you are using to get the best from them and their efficacy. And always read the product label. There's a lot of information on the label that's very useful to the user. Application technology is very important and is advancing all the time, and this is a really exciting area of control. Bioherbicides are very interesting and increasing, but we must understand how they work. Less herbicide modes of action are available, so there's much more pressure on a fewer number of actives. Choosing different modes of action will reduce the overall resistance risk. And you must monitor weed survivors and remove them to prevent resistance. A proactive approach to weed management with integration of alternative methods is really important. So please remember to visit the Operate website for more information on weed control options in horticulture, including many videos from demonstration events and relevant fact sheets. Thank you.